At this time, get out your 5 for Day 3 investigation for quadratics in Google Classroom, and let's get started. So first off, remember the terminology x-intercepts refers to the zeros, the roots, or the horizontal intercepts. You're going to find them by setting the function equal to 0 and either factoring or using the quadratic formula. A quadratic has one root if the parabola only hits it once, perfectly in a spot. Two roots if it crosses over it twice. No roots if the quadratic is either too high or maybe too low for it to hit the x-axis. Now, our domain of any quadratic is all real numbers. This graph stretches from left to right as far as it wants. There's nothing you can't plug in. But the range depends upon the vertex. So remember, our vertex is HK. If our A is positive, our parabola looks like that. And so our range goes from K up to infinity. If our A is negative, our parabola is upside down. So our range goes from negative infinity up to K. Now, the y-intercept is the vertical intercept. It is where x equals 0. So it's the nicer one algebraically. You just got to plug in 0. So these all have just those one spot where it hits the y-axis. All quadratics will only ever have one intercept. You just got to plug in 0, see what you get. Now let's talk about vertex form versus intercept form. Vertex form, you clearly see what the vertex is. You can find that by completing the square or finding your h, plopping it in, finding your k by plugging h into the function and plopping it over here and using that original a. So that's a very helpful form. But sometimes if we're only given the intercepts, you can just plop it into this form that we see here, and then your a value will still be necessary. It will tell us, if it goes upward or downward. Remember, your vertex is smack dab in the middle of those intercepts. So now let's look at two examples that uses that intercept form. It says, find the quadratic function whose roots are 5 and 4 through the point 0, negative 20. So I've written that intercept form right here. And so let's plop in our intercepts. So we know that that would be a times the quantity of x minus 5 times the quantity of x minus 4. So you always change those signs. So you'll notice the 5 and 4 were positive. In the formula, they become negative. It's always the opposite of what they were. Now, they don't give us the a value, and that's why I've highlighted this point right here. Let's take that point out and let's solve for an a value. So when I plug in 0, I get negative 20. So when I plug in 0, I should get negative 20. So that's a times negative 5 times negative 4 should be negative 20, or 20a is negative 20. That's very easy to solve. Divide both sides by 20, you get a is negative 1. So f of x, now put everything back in. Our a value is negative 1. Then we have x minus 5 and x minus 4, and then we are done. Now what you can do is you could open up Desmos, put in the new equation you found. Does it go through the point 0, negative 20? Check. Does it hit the x-axis at 5 and 4? Check, check. And then you know that your function is correct. Now, for part 2, I've started a little bit. It says find the quadratic function with roots 2.5 and 5.8 through the point 0, negative 36. So I plugged into that intercept form. I don't know my a, but I haven't used this yet, so let's use that to help us. So I know a times 0 minus 2.5 times 0 minus 5.8 should equal negative 3.6. Now, negative 2.5 times negative 5.8 is 14.5. So 14.5a should equal negative 3.6. Now, if you put in negative 3.6 divided by 14.5 into a calculator, you get a large, disgusting decimal. I am not going to take the risk that they're going to mark it wrong. So I'm going to leave it like that. And my function then would be that yucky division, that fractional negative 3.6 divided by 14.5 times x minus 2.5 and x minus 5.8. Okay, so that is some example of finding the function. Now in question 3, we're going to do the exact same thing. It's just got some words wrapped around it. So don't freak out. Use everything that we've just talked about. It says a penny is thrown from the top of a 33-meter building and hits the ground 3 seconds after it is thrown. The penny reached its maximum height above the ground 1 second after it was thrown. Define a quadratic function h that expresses the height of the penny above the ground measured in meters as a function of the number of seconds elapsed since the penny was thrown, which we'll call t. Okay, so we know that h of t is the height of the penny in meters. Okay, so what do we know initially? Well, at time 0, we were at a height of 33 meters. We're standing on top of that building ready to throw our coin. At 3 seconds, it hits the ground. So at 3 seconds, we're at a height of 0. So we have those 2 points. We also know that the penny reached its maximum height above the ground, or 1 second above the ground. So we know that the vertex is 1 something. Now I'm just going to call it h of 1. We'll fill that in later, okay? Now it says, define a function h that represents the height of the penny. Okay, so let's go to our graph paper. Now I've fixed my graph paper a little bit. My x's are fine, but my y's I needed to count by 5. And remember, we have the point 0, 33. We have the point 0, 3. We know our vertex's x is at 1. So let's kind of put in what we know. So here is approximately 0, 33. Here is, sorry, I got that switched, is 3, 0. Okay. And I know that my axis of symmetry has to be at 1. Okay. And so because of the symmetry, if I am 2 away for my 1 intercept, I have to be 2 away to the other direction for my other intercept. So let's put that on there. Okay, so I actually get a bonus point. I also have a root at -1. Okay, so I know my parabola is going something like this. And I even know that I'm at 33 here as well. Okay, so that's what I know so far. Now let's think about the question we had earlier. Okay, we knew our 2 roots. So we know a 3 and -1 are our roots, okay? We have an extra point, 0, 33. So that's exactly like the problems we just did. So what do we know? Well, we know h of t is a times x minus 3 times x plus 1. Remember, both of these will change sign. I know if I plug in 0, I better get 33, okay? So I know a times -3 times +1 better equal 33, or -3a equals 33. Now that's easy to solve. I know that A would equal negative 11. So now I've got my equation. H of t is negative 11 times x minus 3 times x plus 1. So once you find your A, you're just putting it back into that initial setup. So now it says, what is the maximum height of the penny above the ground? What's the vertex? Maximum vertex, maximum vertex. Remember that. Okay. So I already know that it happens when t is equal to 1. So let's plug in 1 to our newfound equation. That would be negative 11, times negative 2 times positive 2, or the height would be 44 meters. So let's put that on our graph paper. We know that our vertex happens at 144. And now we can draw our parabola. Now, in the context of this problem, let's kind of highlight the domain in the real life context. Time 0 to hitting the ground at time 3. So that's like the real life thing that has happened, okay? So that is about 5-4 day 3. Turn this in now, then open up your iMath and work on your 5-4 day 3 homework that you should see on the calendar. Okay.